Hello everyone, welcome back to my channel. Today we are going to learn a new chapter of mathematics, class 9th, that is quadrilaterals. So here first, before starting quadrilaterals, we need to discuss certain points. Okay, so what is that? The first, we need to learn about the figures which we'll use in the quadrilaterals. Mostly quadrilateral is nothing but a simple closed figure bounded by 4 line segments, any 4 line segments, but it should be 4. So any line segment, okay, simple, any closed figure which is bounded by 4 line segments, we call it as a quadrilateral. Okay, so in quadrilateral also we are having different quadrilaterals. So let us study. The first is nothing but trapezium. What is that? Trapezium. So trapezium is nothing but, here in trapezium, one pair of opposite sides will be parallel. Okay, suppose this is a figure like this. The figure will be this and this. Okay, so here a quadrilateral in which one pair of opposite sides are parallel is called trapezium. Means this is parallel to this. Okay, so the opposite sides are parallel in a trapezium. Next, let us study parallelogram. Parallelogram. So this is the next figure, parallelogram. So in this, the quadrilateral in which both pair of opposite sides are parallel is called parallelogram. Means this and this is parallel, right? And this one is parallel. So any figure in which both the pair of lines are parallel to each other, that we call it as a parallelogram. Okay. The next is nothing but rhombus. Rhombus. In rhombus, what will happen? Adjacent sides will be equal. In rhombus, what happens? Adjacent sides means this adjacent side, this is adjacent, this is it. These two sides will be equal in a rhombus. Okay. Next, rectangle. Rectangle means rectangle. In rectangle, opposite sides will be equal. Okay. And also one angle will be right angle. If you divide this into two, if you draw a diagonal, that will be right angle. Here one right angle, here one rectangle. So rectangle is nothing but opposite sides will be equal in a rectangle, and when it is dividing, when we are dividing that with one line, it will be, there will be one angle, that will be right angle. Okay. The next is nothing but square. In square, all the sides will be equal. In square, all sides will be equal. Where this will be equals to this will be equals to this and this. So this will be a square. So adjacent side and also adjacent sides will be equal, and also in this also one angle will be a right angle. Okay. The next is nothing but kite. Kite, we must have seen the kite, right? So it will be in this form. So in this, what happened? Two pair of adjacent sides will be equal. This side will be equals to this. This side will be equals to this. So this is nothing but kite. So these are the important figures which you need to understand before starting the exercises. Also, there are certain features of this figures. Okay. So in a parallelogram, the diagonals, if I am dividing any figure, if I am dividing it with one line, that is, this will be nothing but your diagonal. So the diagonal will bisect each other. Next is consecutive angles are supplementary in the parallelogram. The opposite angles will be equal. Both pair of opposite angles will be equal. Okay, and the diagonal divides the parallelogram into two congruent triangles. So this is nothing but the properties of parallelogram. In a rhombus, diagonals bisect each other at right angles and the diagonals are unequal. This and this. So diagonals will not be equal in a rhombus, whereas in a parallelogram it will be equal. Next is in a square, diagonals are equal. If I am dividing two, I am drawing two diagonals. So here diagonals will be equal in square and they will bisect at each right angle. Okay. Next, in a rectangle, diagonals are equal. Diagonals will be equal in a rectangle, they will bisect each other. Okay. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and also the half of it. The line drawn through the midpoint of one side of a triangle midpoint of one side of a triangle parallel to another side will bisect the third side. Okay, this is nothing but the property of it. The intercept made by the transversal or three or more parallel lines are equal to one another. So these are nothing but the things which you need to understand before starting the exercise. Let us start the exercise now. In exercise 8.1, state whether the statements are true or false. So in this, the first statement is every parallelogram is a trapezium. Yes, we have discussed both the features of parallelogram and trapezium, and so it is true because every parallelogram can be trapezium. Next, all parallelograms are quadrilateral. That is also true. Next, all parallelograms are all trapeziums are parallelogram. No, because in parallelogram we can see that the opposite sides are equal. Okay, whereas in trapeziums you have seen the figure, right? Whereas in trapezium, it's not like that. So parallelogram is different, trapezium is different. So this is nothing but false. A square is a rhombus. This is the square, this is the rhombus. Can a square be a rhombus? Right? Because we can make it, but every rhombus is a square. No, this can be possible. So that is false. All parallelograms are rectangles. False, because in rectangle we are having opposite sides are equal and there will be one right angle triangle. Okay, so this is nothing but your first question. Next, question number 2. In question number 2, you have to complete the following table by writing yes if the property holds for the particular quadrilateral and no if the property doesn't hold. So here we are having only one pair of opposite sides. So you can like this, the table is only one pair of opposite sides are parallel. Trapezium, yes. Parallelogram, what's the answer? Only one pair of opposite sides are parallel in a parallelogram. No, because in parallelogram all four sides are equal, right? In rhombus, what is in rhombus? Yes, one pair is for parallel. Yes. Next, in the rectangle, yes. In a square, all pairs are parallel. Okay, because they are having equal, right? So this will be yes. So like this you have to do for the question number 2. Okay, the next is question number 3. In question number 3, what we are doing in question number 3, let us write the question first. A B C D is a trapezium. A B C D is a trapezium. Okay, A B C D is a trapezium in which AB is parallel to CD. Okay, AB is parallel to CD if AD is equals to BC. If AD is equals to BC, show that angle A is equals to angle B and angle C is equals to angle D. So this we need to prove. ABCD is a trapezium in which AB is parallel to CD. If AD is equals to BC, show that angle A is equals to angle B and angle C is equals to angle D. So here first we'll draw that trapezium. Like this, the trapezium will be, yes, both pair opposites, 1, 2, right? A, B, C and D. Okay, A, B, C, D. Next, what they are saying, if AD is equals to BC, if AD is equals to BC, show that angle A is equals to angle B. So AD is equals to BC, they are saying. Okay. Next, also let us take one more point here, E. Okay, I am taking one more point, E. So if I am taking a parallel, if I am making some kind of triangle, so here this will be angle A and this will be angle B, this will be angle C, right? Angle E, right? A, B, C, D. This is nothing but the direction of it. Okay, now, so here why we are marking this E? Because we want to make it as DE as DC is equals to AE. DC is equals to AE. So that's why we are marking it as, because we are making a parallelogram here. Okay, now, first we'll write the given things. Given that triangle ABCD, quadrilateral ABCD, AB is parallel to CD and AD is equals to BC. Okay, mark point on E, mark point as E on AB, because on AB we have drawn, right, such that DC is equals to AE. Now whatever we have done, that we have to write, join E comma C. Okay, Now in quadrilateral AECD, so AE is parallel to DC. A is parallel to DC, yes, since it is a parallelogram, and angle DAE is equals to angle CEB, right, corresponding angles. Next, this let it be 1. And next, in triangle CEB, in triangle CEB, CE is equals to CB, right? Therefore, angle CEB is equals to angle CBE, because opposite angles will be equal, right? Let it be 2. Okay. From 1 and 2, triangle DAE is equals to, right? DAE is equals to the angle CBE. This will be equals to this, since CED is nothing but CEB only, right? So here this will be equals to this, and therefore angle A will be equals to angle B. Also angle D is equals to angle AEC. Angle D is equals to angle AEC, right? Since opposite angles, right? So next is what? So this will be equals to angle ECB. AEC, I am dividing AEC to ECB plus angle CBE. Okay, since AEC is the external angle of BCE. Okay, now next angle ECB plus angle CEB. Okay, since angle CBE is equals to what? CEB, right? Next, angle ECB plus angle ECD, because CEB is nothing but alternate angles are there. So since angle ECD is equals to angle CEB are at what? Alternate angles. Okay. Next, angle, this will be equals to what? Angle BCD, which is equals to angle C. So therefore angle C will be equals to angle D. So like this you have to calculate that question. Okay. Next is your question number 5. Question number 4, sorry. The four angles of a quadrilateral. The four angles of a quadrilateral are in the ratio 1:2:3:4. Find the measure of each angle of the triangle quadrilateral. So given, what are the ratios they have given? Ratios of angles of quadrilateral. Ratios of angles of quadrilateral, which is equals to 1:2:3:4, right? So sum of the ratio will be equals to what? 1 plus 2 plus 3 plus 4 is equals to what? 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. And also sum of interior angles of a quadrilateral, sum of 4 interior angles of a quadrilateral is equals to how much? 360 degrees. Okay. So first angle will be how much? First angle will be equals to 1 by how many total number of parts? 10. And the total angle is how much? 360. Right. So 10 ones are 10, 36 are. First angle is 360. What is second angle? 2 by 10. Second angle, right? 2 by 10 into 360. Again, 36 twos are how much? 72. Right. What will be the third angle? 3 by, third angle is nothing but 3 by 10 into 360. 3 into 360, 36 is how much? 108 degrees. What is the fourth angle? It's an easy one. 4 by total number of parts, 10 into 36, 360. 10 ones are 10, 36 are. 36 fours are how much? 144. So what are the angles? 36, 72, 108 and 144. Okay. By this we have done this question. Okay. Next is question number 5. So question number 5 is ABCD is a triangle. Let us draw. Okay. A, B, C, D. ABCD is a rectangle. AC is the diagonal. Okay, this is the diagonal. Find the nature of angle ACD. Okay, so this will be anyhow 90 degrees, right? So first, what they are saying, in triangle ACD, what will happen? Angle D will be equals to how much? 90. Okay. Next, angle A plus angle C is equals to how much? 90 degrees, since it is nothing but a triangle, right? Next, angle D is the right angle triangle. So here angle C and angle D are nothing but complementary triangles, because in a quadrilateral, or since we are already having that this is equals to 90 degrees and one is equals to also 90 degrees. So therefore angle A comma angle C are nothing but complementary angles. That's it. That's it. By this we have completed this exercise. Exercise 8.2, question number 1. So in your first question, the given figure ABCD is a parallelogram. Let us draw a parallelogram. ABCD. Okay. So this is nothing but your parallelogram. All opposite sides will be equal. ABCD. Okay. ABEF is a rectangle. AB. One more we need, right? That is nothing but E. F. So ABEF is a rectangle. Okay. Show that triangle AFD is equals to triangles BEC. This we need to show. Okay. Let us do it. Right. So here given, first we'll write the given things. Given ABCD is a parallelogram. Okay, parallelogram, right? Next, triangle ABEF is a rectangle, right? In triangle AFD and triangle BEC, AF is equals to BE, right? Because it is a rectangle, right? Opposite sides will be equal. And AD is equals to BC, right? Opposite sides of the parallelogram will be equal. So by this you can see DF is equals to CE. Since here also in the diagram you can see that both are equal. So therefore triangle AFD is similar to BEC because all the sides are equal. So by the SSS congruency, all sides are equal. Okay, this is our first question. So here we are having similar question in these exercises. All the questions are similar only, so we can do that. Next is exercise 8.3. Exercise 8.3, first question. The opposite sides of the parallelogram are given. Opposite sides of parallelogram. What is the opposite sides of the parallelogram? 3x minus 2 degrees and x plus 48 degrees. Find the measure of each angle of the parallelogram. So here, since opposite sides of the parallelogram means this will be equals to this. So 3x minus 2 is equals to x plus 48. Taking x this side, 2 that side. So 4x, 3x plus x is 4x. Sorry, 3x minus x is 2x. 48 plus 2 is how much? 50. So 2 1s are 2, 2s are 4, 2 5s are 10. So the value of x is how much? 25. So it means one angle is what? 3 into 25 minus 2. 5 3 is the 15, 3 is the 6, 7. 72 minus 2 is how much? 73 is the one angle. Next is x plus 48. Means it is 25 plus 48, which is equals to how much? 8. 5 5, 10. 10 plus 3, 13. 4 plus 1, 5. 5 plus 2, 7. 73. So all angles are how much? 73. Okay. So here the other two angles will be how much? If this is 73, the other two angles means 180 minus 73. So 180 minus 73 will be how much? 107. So the angles will be how much? 73 comma 73, 107 comma 107 will be the angles, 4 angles. Okay, it's an easy one. Okay, so let us continue this exercise in the next video. Thank you for watching. Please like, share and subscribe to my channel for more videos. Thank you.